This is Mr. Beck Does Your Homework. This is homework 6 for physics, question number 5 and 6. This is a tricky question. A lot of people have trouble with it, but it helps if you draw yourself a picture. A daring stunt woman sitting on a tree limb wishes to drop vertically onto a horse galloping under the tree. So what's that going to look like? I'm going to have a nice stick figure horse here running along with, I never know how to draw these things. There's my horse with a little mane, and he's got a saddle, and he's got a tail. So there's my horse. Now I've got a tree. Here's my tree. And I've got a tree limb sticking out. And so here's my tree limb. Here's my tree. And here is my daring stunt woman who is sitting on the tree, and she wants to jump down and land on the horse. So let's see what that says. A daring stunt woman wishes to drop vertically onto a horse galloping under the tree. The constant speed of the horse is 15.4 meters per second. So this horse is zipping along at 15.4 meters per second. Keep that in mind. But that's not the woman, that's the horse. The woman is initially 1.3 meters above the level of the saddle. So the woman has a distance here of 1.3 meters that she's going to fall. How long is she in the air? The acceleration of gravity is 9.8 meters per second squared. So I know that g is negative 9.8 meters per second squared. Now she's going to fall 1.3 meters, so that is her displacement, but her displacement is going to be negative because she's going to fall down, so negative 1.3 meters. I also know that since she's falling from rest, she's dropping from rest, I know that her initial velocity is 0. So first we're asking about her. We don't care about the horse, so this number does not come into our first part of this problem. So this lady is going to, this stunt woman is going to fall 9.8 meters per second for 1.3 meters as she falls, starting from an initial velocity. I'm looking for the time in the air. So do I have an equation that relates time, initial velocity, displacement, and gravity? I do. It says that my displacement is my initial velocity times time plus 1/2 the acceleration of gravity times time squared. Now you might get worried here and see time and time squared and say, oh my gosh, this is going to be quadratic, but luckily I've got a v0 here that is 0. So let's see what happens here. I've got negative 1.3 equals initial velocity of 0 times time, good, so that goes away, plus 1/2 the acceleration of gravity, negative 9.8 times time squared. So I multiply by 2 times negative 1.3, divide by negative 9.8, and that is going to equal my time squared. So when I square root that, I will get myself my time. So time equals, and then square root that. Now part 2 says, what must be the horizontal distance between the saddle and the limb when the woman makes her move? So now I really want to know, how far does the horse move? So how far does the horse move this direction in order that the woman can land on top of her? On top of the horse. So if this distance is what I'm looking for, I'm going to call that x. So I know the velocity of the horse. I want to know the distance the horse travels, but now I know the time over here. So I know that my position in the x world is my initial velocity times time plus 1/2 the acceleration times time squared. But wait, this horse is not accelerating, it's moving at a constant speed, so this acceleration is 0, so this whole term goes away, and all I'm left with is my position of the horse is my velocity times my time. So how far the horse has to run is going to be its initial velocity, in my case 15.4 meters per second, times the time, and the time is the same time as the woman had over here, so that time goes in here, and you will wind up with a new, with a distance that the horse travels.